Hi, everybody, and welcome to another AIA Colorado Virtual Connect. We're glad you're here. Today's session features a conversation on codes and architectural solutions related to fire and smoke separation from our good friends at Powers Products. Our presenter today is Keith Lunsford. Keith's going to help us analyze the pertinent codes and design solutions for a variety of building types, including hotels, multifamily, schools, offices, high-rise, municipal, and healthcare facilities. I encourage you to use the chat box to ask questions. I'll help moderate the discussion after the presentation. But Keith tells us that if you have a question during the session, that they'd be happy to answer it at that time as well. In addition, and most importantly, AIA members will earn one AIA CES Health, Safety, and Welfare Learning Unit for participating in today's webinar. It's my pleasure now to introduce our speaker today. Keith Lunsford is the product manager of fire and smoke separation solutions at Powers Products. Hey, Keith, there you are.
Hey.
He brings more than 20 years of experience in specialty commercial doors to the Powers Products team and provides technical code, design, specification, and pricing support for several specialty commercial door systems. Keith is a professional affiliate member of the Society of Fire Protection Engineers, as well as the Colorado chapter of the International Code Council. Joining Keith and working in the background to help answer your questions is Gary Dvorak. Gary's an architectural engineer in charge of business development at Powers Products. He will mostly have his smiling face seen in still mode today, but he'll come on for questions with the video. We're glad to have Gary here, back once again from a session that we did last year. We are so grateful to have Powers Products as a sponsoring partner at AIA Colorado. In addition to providing quality continuing education webinars like this, AIA Colorado partners allow us to offer many of these programs at no additional cost to members. So thank you, Powers Products, for all that you do to support the profession. And without further ado, we'll have Keith tell us more. Thanks.
Sounds great. Thank you, Mike. And yeah, like you said, don't be afraid to ask questions as we go through. This is a lot easier for me if there's some conversation throughout the presentation. And to save some bandwidth, I am going to turn my camera off through the presentation as well. This is a presentation that we put together in-house, so it's not one manufacturer trying to not to talk about themselves the whole time. We actually have several different product types that are covered throughout this presentation. We'll be talking about some of the history and requirements of smoke and fire protection for openings in firewalls, fire barrier walls, and some atrium work. There's also 3 other wall types that are addressed in the code, and we may touch on those just a bit. Really talking about how the use of wide span opening protectives help create a healthy built environment, some IBC requirements, and some of the innovations that we've come up with to kind of help meet those requirements. And the best part is the second half of the presentation is case studies. So lots of cool photos and trying to keep the number of words to a minimum throughout the presentation. So why we need fire and smoke presentation. This is probably the most studied fire, even though it was back in the 80s. It's still a really well-studied and well understood fire. There were 85 fatalities in the MGM Grand Fire. And you can see by this little chart we've got where all the deaths were per floor. The fire never left the first floor. So that's super important to understand. With all of these deaths throughout the height of this building, the fire never left the first floor. Smoke really moves efficiently through buildings and really is the largest cause of building damage, as well as death and injuries. So it's just such an efficient machine moving through buildings. So we really want to contain the smoke almost more so than the fire. Another project here in 98, 4 people died in this escape stair shaft because of smoke inhalation 10 stories above the fire floor. So it's super efficient. Not only does it spread laterally through a building, but vertically as well. So we really want to try to contain the smoke as quickly as possible. Kind of a fun thing to talk about is how people react in a fire. It's not like people get out as soon as the fire alarm starts to go off.
In fact, typically the exact opposite happens.
Well, unless somebody starts singing "Smoke Gets in Your Eyes," I think We may just start and go on.
When the fire alarms go off, people tend to ignore the signal, often seeking more information before acting.
Are we supposed to leave? Not yet. That's not an encouraging answer, not yet.
In fact, a significant amount of time may pass before any evacuation sequence is initiated.
So that's really important to know is we always study this, egress times and those types of things, but there's a reaction time that really starts the clock ticking, and we just don't always get out of buildings as fast as we can. There's also that we tend to exit the building the same way we entered. So even if we're going, and grocery stores are the classic example, right? We all know the front door. We all go in the front door of the grocery store. But even if we're in the back corner where the milk is and an alarm goes off, most people go back to the front door to get out of the building, which is super dangerous. And one reason why the entrance of a building needs to be, capable of handling such a large portion of the capacity of a building, because we all go back out the same way we came in. So something else to keep in mind. Something else is people don't always, this is a delayed response that we kind of saw with President Clinton. This one's a little quicker reaction, but still doesn't, make it much better. And if anyone's a fan of The Office, this is a clip that Gary had come up with.
Oh my God! Oh my God!
Fire! Oh, fire! Oh my goodness! What's the procedure? What do we do, people?
The phones are dead.
Oh, how did that happen?
It's out in the hall.
No, we don't know that. The smoke could be coming through an air duct.
Oh my God! Okay, it's happening. Everybody stay calm.
What's the
Everybody
procedure,
stay calm.
everyone? What's the procedure?
Stay calm!
Wait.
Everybody calm down!
Ah, my hand, that's hot.
This one's hot too.
Okay, we're trapped. Everyone for himself.
Okay.
Here we go. Let's go. Get out of my way.
Okay. Oh,
So another way that people can react, it's not always accurate. Very rarely is there a true panic, unless we wind up in a building like some of the the venues that we've talked about or read about in the past, where people get stuck and there's only one way out. Otherwise, this is not normally the reaction to a fire in a building. So a firewall is a very structural concern, a structural portion of the building. Couple things that you really need to keep in mind is it must extend from the foundation through the roof, and it has to have enough structural stability. So even if there's a fire on one side of the building, even so much as a roof collapse, that firewall must maintain its integrity, protecting the rest of the building. Fire barrier walls have a lot shorter definition. Again, we're containing smoke and fire within in the structure, but it's not quite the structural requirements or structural stringency that we'd have with a true firewall. And then when we need to be able to pass through these buildings, we need to open up these walls. So that's really what we're going to be talking about a lot today, is the fire protectives or fire doors that are used in these different applications. We're not a door manufacturer. We're a distributor. We work with several manufacturers. But for the ease of communication, I'm going to pretend I'm the door manufacturer today. So it's just easier to kind of go through this firsthand. So we know doors have to have fire resistance ratings, but not everybody understands what it takes to get those. What we do is we'll build a door up to a 13 by 12. That's really the largest door that you can get in testing labs in the U.S., be it Intertech, Warnock Hersey, FM. All of those companies are really limited in lab sizes at about 13 by 12. So we'll design that door. We'll install it right on a wall model on site. It'll either be attached to like a masonry wall, if that's what we're trying to get our label for, or steel stud and drywall, or structural tubes, or something like that. So we'll install that door, and then they'll burn that door at 1800 degrees for up to 4 hours, depending on the fire label that we're trying to get for this particular product. Once we're done burning that door and it maintains its integrity, there's no flame through for that. Typically we'll call it a 3-hour test. That's probably the most common test that you see done. They'll slide that entire assembly away from the furnace, and then they're going to spray it with a fire hose. And that's called the hose stream test. And this hose goes back and forth, side to side, as well as up and down. And the intent of that is to make sure that door maintains its structural integrity, basically through a fire with pressures against it. Anytime there's a fire in a building, there's a lot of pressures pushing out against, all four walls, the floor, and the ceiling. So we're simulating that with this fire hose test. Once we get that test done on that 13 by 12 fire door, the testing agency will let us build a door up to that size and put a label on it. As long as we maintained, consistency with the door that was tested through our production process, they actually trust us to put those fire labels on the doors. We also, again, I was talking about smoke at the beginning, so we also need to make sure that we maintain smoke and draft protection. And that's what we see here is this fire label. If you read underneath the serial number, it says smoke and draft control rating. One thing that's really important, it's a bigger issue on swing doors than it is some of the wider span doors like we usually deal with in my division, is these doors have been tested for smoke and draft with a gasket on them. And it mentions it right there on the label. The problem is most doors don't ship with gaskets, or don't ship with the gaskets attached. They ship with the gaskets with the hardware. And this label is absolutely void if the gaskets aren't installed in the field. And probably more than 20% of the doors I've taken a serious look at have been installed without the smoke gaskets. So it's still a rated fire door, but they don't pass this smoke label, which, they've got the label, but they've not been installed properly to achieve that. So I mentioned the limited size of a door, the 13 by 12. We frequently need a larger door than that. So we'll design a larger door, send all that information back to the testing agency. They'll run their calcs and they'll respond saying, yes, we believe this larger door will perform exactly as the one we tested. And they'll give us an oversized certification or an oversized label. That's valid everywhere in the US. The IBC accepts it. The only nuance is in the life safety code, that oversize approval is left up to the AHJ. And we happen to live in the one state that has an AHJ that does not allow an oversized door in a facility. So if you're building a hospital, a nursing home, something that requires the state's approval for CMS, you will not be allowed to have an oversized door in it. Again, it's just a Colorado thing, and it's just in healthcare in Colorado. But it's important to note, if you have an oversized door, it will not be accepted by that group. We need doors to be automatic closing and smoke activated. So as soon as we start sensing smoke in a building, we really want to start shutting these facilities down to keep them as safe as possible. Again, smoke is just so efficient the way it works and flows through a building.
Keith, a quick question here that just came through. There was a question at some point when you have time. Have you had any issues with the NFPA 221 version of the firewall?
I don't know what that is. Is that where we've got two walls back to back? Yeah,
it's a high challenge firewall, and it is a structural element.
So if that's the one I'm thinking of, the issues that you would have is building two walls that are back to back and trying to get egress through them. It gets very complicated. We see those double walls done a lot in like building additions where there's an existing building and the exterior wall actually becomes an interior wall and part of the firewall, for the expansion of the building. So I don't know if they're concerned about the egress. A lot of times we'll do like a factory mutual type layout where there's two fire doors back to back. So there's one door installed on each wall, but there's no egress on those. It's usually just like a straight coiling door or a sliding fire door. To get egress, you've got to start building vestibules and those types of things. So it gets a little trickier. I don't know if that answers the question.
Yeah, he did confirm it was a double firewall condition. Okay. So yeah, thanks, Keith.
Absolutely. So different opening protectives serve different purposes. We're going to kind of go through some different products. But one of the needs for wide span opening protectives is helping bring daylighting through buildings. So we're opening up, all these compartments that the code kind of wants throughout the facility. We can open those up and bring the fresh air and daylighting throughout a building. We can also do it vertically down from skylights or solitubes down through atrium spaces and those types of areas. So this is one of the applications you can see with the side acting fire door open, that nice open stair providing communicative space. You can see it's kind of a 3-story space we're looking at here. Lots of light coming through, and then obviously the ventilation helps with the wellness throughout the building. Another application with a coiling. This is a draft curtain, even though it's about 8 feet tall. This door doesn't even need to go down to the floor. It closes off compartments to separate atriums and some other spaces, so that the closely spaced sprinklers do get activated with smoke, versus having the heat and smoke kind of spill up through the atrium space. Another view here, closing that space off again for smoke and draft and heat, but still allows for freedom of movement throughout the facility without creating egress concerns. This one here is a hospital with some open corridors. With these open, it's really easy to communicate through the building, to travel throughout the building. But should there be an emergency, we can close it down with these 3-hour fire protectives. And the ones on the right here actually allow for egress. This is a dual egress on the right-hand side. So we can still get people, through these wide open corridors, even after the fire doors have closed. Another great daylighting and actually a marketing example is this one here with this coiling door in the open position. We've got, this nice open convenient stair throughout the building. You can see the daylighting and all this well lit marking materials in this store. But once it closes, we're containing the smoke and fire to prevent it from getting into that convenient stair that penetrates up through the building. Another example here in this atrium space, you can see on the top floor they've got this glass with closely spaced sprinklers. That's allowed in atrium spaces. You can actually get a 1-hour rating. There's a few nuances, but almost any glass and almost any sprinklers, as long as they're closely spaced, can be used in this application to create that 1-hour protective. The drawback of the glass is you lose that communicative area between the floors, as well as the ventilation there's no ventilation with the glass installed. If you look at the center floor, you can see that side coiling fire door across that space, doing the same thing, creating this containment within the atrium. But when it's open, you get that wide, containment type space. Another one here with this vast, really huge atrium space. But should there be an emergency, the coiling doors come down, containing this space. But the rest of the time when it's on standby, we've got, just a huge, well-lit, well-open space. This is a local project we did with Anderson Mason Dale. This is up at Colorado School of Mines. It's a really cool 3-story atrium space, great, community type space, the convenience stairs. And we're seeing a lot more push for convenience stairs, as opposed to having people, lock themselves in elevators to move throughout a building. Just a lot more ventilation and separation allowed by using stairs versus elevators. So we're really starting to see more and more stairs used in this building, or in these types of buildings. And then above the stairs, the floor above that, if you look, you can see a little slot in the wall there to close that space, or that kind of shows, in the wall there. That's a horizontal fire shutter. So it closes off and isolates the 3rd floor from the lower 2 floors, which eliminated the need for any smoke control in the building. So some different ways to protect buildings. We've got different types of doors. We'll kind of go through these a little bit at a time. So steel fire doors, we can have them with or without egress. The advantage of steel is everyone understands how they work. We can have egress incorporated. We can go up to a 4-hour rating. Fire doors can be really, really wide. We can do up to 80-foot openings with a lot of these. The coiling, the products that coil from up above only need support at the jambs. We don't need any structural support, between the jambs up above the hood or anything like that. Most of our side acting doors wouldn't need a floor track unless we get into some special circumstances where there's a lot of different pressures in the building, or we get to a certain height where we're worried about the door swaying.
Keith, just sorry to interrupt. We have another good question. I think it's good timing. Can you elaborate on the automated sensor process that would trigger these firewalls to close?
Sure. So almost all doors are tied into a central alarm system. The code requires that a smoke detector on either side of the door be used to activate the fire doors. Frequently, we see the AHJs want most of the doors within a building tied to a general alarm, so they close more often. Nuisance closures, are something to note, but it's life safety is also very important. With very few exceptions, and we'll actually address one of them. All of the fire doors that we really see in the industry today are fail safe. That means if the power goes out, the door is going to close. If a motor fails, the door is going to close. If the alarm system fails, the door is going to close. So we do everything we can to protect those openings. Fusible links are kind of gone away, where we used to have these little melt links that would heat up to 165 degrees somewhere up above the door, and then they would drop the door. The electronic systems seem to work much better. Problem we see with fuse links is they're not installed properly. Or in the case of like a discount tire, they spray paint those buildings every other year, and I swear they squirt paint out of a garden hose. They put so much paint on the walls. So they paint over those fusible links, and then they don't function anymore. Or putting a fusible link, above a ceiling kind of defeats the purpose of protecting a corridor, right? If the fire's in a corridor, a fusible link up in the plenum space doesn't do much good. So I hope that answered the question. So what we're looking at here, this is a coiling fire door that has egress doors that are held open kind of in an adjacent pocket. So when the alarm goes off or power fails, these doors and frames swing out into place. They lock into place. And then the coiling door comes down around to close that area off. We can go up to about 60 feet wide with something like this. We've got egress, compliant egress doors. This door takes about 18 inches of headroom and a little bit of space for the pockets to the side. A lot of what we'll be talking about on these doors is storage. Where do we put the door when it's in standby mode? Nice clear opening we've got here, but we've got a 3-hour fire protective that comes down and closes it off. This door doesn't need the pockets off to the side, but does take about 10 feet of headroom up above. So this type of door seems to work better in ballrooms and theaters, some schools with gymnasiums. We're kind of using them in those spaces where we've got some really high decks to begin with, and we need to get a lot of people to egress, through this type of space. This is a side coiling door, or actually this is a side acting door. So it kind of slides like a barn door. You can see the track in the ceiling, kind of a curved track there around the stairs, and some really odd placed exit signs. When the door is in standby, those exit signs don't seem to make much sense. But if there's an emergency, these sliding doors come around and close this whole staircase off. And then you can see the egress doors at the end of that radius there. So people can egress, from these stairs out of the building. So another side acting door. This is a side coiling door. So this one coils up into like a 4-foot by 6-foot closet space. An advantage of this door, and actually the previous one here, we only need 6 or 8 inches of headroom for the track up above. So it's a really compact model. We're storing the door off to the side instead of vertically. Accordion fire doors. There's really two types of accordion fire doors. This unit is fail safe. You can see the egress door on it. Again, if power fails, the motor fails, something like that, this door is actually pulled closed by gravity. There's counterweights within the wall that pull these doors closed. We can put egress doors in them. And there's some different profiles and pockets that can be used. The traditional accordion doors, there's multiple manufacturers that make this product. A couple things to keep in mind. One, there's no egress door in it. The entire product is the egress door. We'll kind of see here, there's a paddle on the door that you push and the door will open up. That furniture is pretty unfortunate, so they have to open the door a little bit further than you'd normally see. But you push that paddle on the door to get it to open. And this door is not fail safe. We're actually relying on a motor and electronics and battery backups to keep this door functioning. But a big drawback to the door we're looking at is when that door is open, even when it was open just a couple feet, there is zero fire protection. You can see that this opening is open all the way to the ceiling. So if the door closes halfway or 3/4, we still have zero protection separating the two spaces. In a fire door like the one on the right, this door closes. It's got the pardon the term, man door, swing doors for egress. But you can see with that egress door open, we've still got 3 feet of protection from the egress door up to the track. And that's the biggest concern when there's a fire in a building. All of the noxious fumes and smoke with the heat go straight up to the ceiling. So even if you've got a door that's open, like we see here, we've got 3 feet of protection. That smoke, as it's billowing to the ceiling, it takes a long time for that smoke to build down enough to spill through the egress door. So a really good comparison between two types of accordion doors in the market. Also, accordion doors, it's probably the biggest nuisance we have with accordions. And this photo is unfortunately a product that we sell, not even pointing at the enemy here. They can drag on the floor and not completely close. So that's just something to keep in mind. And again, we've got zero protection up at this track for this to stop the smoke as it's going through. Accordions are really the highest maintenance product. AHJs don't necessarily like them. It's much better with the egress, the swing doors built into them. But it is kind of a nuisance. We try to avoid accordions when we can. Another drawback is this door does not open in the direction of egress, right? It's perpendicular to the direction we're trying to get people out of a building. So even though it's got an egress paddle on the door panel, it's not always the best product to be using for life safety and getting people safely out of a building. So this is a rolling fabric curtain. There's multiple curtains on the market. It's something to keep in mind. What we see here is a smoke and fire rated curtain, but this one does not pass the hose stream test. Very few curtains pass the hose stream test, but they're still compliant for use in association with Atrium smoke evac systems and those types of things. So they do work in certain areas, but not others. There's also an egress flap that's provided in these doors. Please don't spec these for cross corridor or something. It's truly a flap. It looks like a triangle shaped tent flap. So even if a manufacturer is telling you it's ADA compliant, that's really kind of fudging the truth, in my opinion. We kind of compared costs on a couple different types of doors. I had a job I was looking at with a 17-foot wide opening, 10 feet high. We compared the accordion fire door at about $47,000, the fabric curtain with the hose stream test. So this is the newest product on the market. It does pass the hose stream test. Really similar cost between the two door types. You can see a substantial difference with weight. The accordion weighed about 1,300 pounds. The coiling curtain weighs about 500 pounds. Also, the curtain is just jam supported up to about 30 or 40 feet wide, where accordions are just header supported. So there's a lot of structure that needs to be included with that accordion door. We also have a couple different ways to have multiple sided door systems. So what we're looking at here is an accordion door, kind of folds down out of the ceiling. It's a curtain that does not meet the hose stream test. But again, great for atrium type application. No corner posts are required. So it really does keep that space open. We can see it in action. So it just kind of telescopes down out of the ceiling, or accordions down out of the ceiling. The one we're looking at here is 3-sided. So you can see it back behind the stairs in that jamb, and then 2 90-degree turns, and then right above us back to the jamb on the right-hand side. So great way to contain a perimeter. It's super compact. It only needs about 9 inches of headroom. So a great way to keep that compact. And then I had mentioned horizontal shutters a little bit before. We can close off horizontally between floors. And in every application, we've specified these. We've been able to completely eliminate the need for a smoke control system in an atrium. So substantial cost savings and a lot less engineering need to be done. We need to keep in mind the weight of the door system. That's really the only engineering that needs to be done with some structural engineering, but we can completely close off. And we've got projects where we've saved over $1 million versus the need for smoke control in a building. It's also simpler to test. Takes just a couple minutes for qualified personnel to test the horizontal shutters versus bringing in engineers and all these other people that are required for testing a smoke control system in a building. Another way we have to protect buildings is these magnetic gasketing system that can close off hoistways. So we can keep the smoke and draft out of the chimney that's a hoistway, which is super dangerous and really one of the biggest issues for containing smoke in a building is at the hoistway. There's also hold open doors that could be used as an elevator lobby, or additional doors we could use in front of the hoistway or something like that as well. Case studies, my favorite part. This is a project. Actually, I was still out there Saturday night doing some final adjustments in the building. We've got 3 really big horizontal shutters in this building. They're the biggest ones in the state. Up to, I think our largest one's about 28 by almost 40 feet long. So substantial openings, but you can see the intent of this building is really daylighting. They really want to bring daylighting all the way through this building as efficiently as possible. This community building at DU is it's just a great space. Up on top, there's a lounge, there's a rooftop deck. Throughout the facility, there's a lot of meeting spaces, some great places to hang out, a bunch of fireplaces, several restaurants. It's open like a food court and serving some of the finest food in Denver. And they just opened a Starbucks in there. But kind of a section of this building, you can see these 3 green horizontal lines closing off. And this great model down here in the bottom right-hand corner, kind of showing the intent of this open space. So we put those horizontal shutters to close those 3 spaces off. And suddenly we don't have an atrium anymore. It's just a 2-story space as far as the code is concerned. So we eliminated the need to design any smoke control in this building. We do like to be in projects early. It's very helpful with especially the scale of some of these. You can see the openings in the deck. We're installing these doors really early in this project. We needed to make sure all the clearances were adequate, and we needed the architects stayed in communication with some structural engineers to make sure that we were able to put these 16,000-pound doors in these buildings attached to the deck between the second and third stories. So you can see a lot of coordination needed to happen, but the end result is amazing. Forget the construction tent there. I took the picture a couple days too soon, but you can see the end result in this project is exactly as the mock-up we saw at the beginning. So just a really nice communicative space, really open. There's a lot of seating around the space. And even with COVID, they were able to function in this building because the building was just designed so open. Another project we did, this is an atrium space in Grand Junction at the college. This was a remodel. The building is about 25 years old. It already had a smoke containment system, but it wasn't nearly adequate enough to meet today's codes, as well as the expansion that they were doing in this building. And you could see the stairs coming down around this elevator shaft. So kind of a tricky space for this 40 by 40 atrium. We were unable to use a horizontal shutter in it. But what we did is you can see the dashed lines around this atrium space. We were able to put these smoke and fire rated curtains around this atrium to contain it, so that the smoke control system only had to pull smoke and air out of just the atrium space itself, and we're able to ignore the rest of the building, completely isolate it from the rest of the building. Down on the first floor, it was a little trickier, but you can see the dashed lines most of the way around. One issue with smoke control is you also have to bring in makeup air. So we had to, as part of this project, coordinate a way to bring makeup air in to pull it through the building itself. So you can see in the building, the storefront opens to bring in that makeup air. And then we're bringing 19 curtains down throughout this facility to close it off. And you can see at the top floor, they do have that glass with closely spaced sprinklers for some spaces that they didn't really want to be part of the community space. It was some private rooms. Yoga room was one of them. I think one was just a meeting room or something. So just a great way to keep that atrium open. But should there be an emergency, we're closing it off, allowing for that smoke control system to be adequate. Other spaces, hoistway protection is very complicated. Most of it is laid out. If it's a hospital, if it's a prison, if it's a high rise, it has to be protected. The R occupancies, that's a magic one. That's probably the trickiest and misjudged, or AHJs are really inconsistent on how they were enforcing these. We thought it was going to get better with the 2018 IBC. It does state pretty clearly that when the corridors required to be fire resistance rated, elevator openings shall be protected. The tricky one is what happens on the first floor. Most AHJs are still not enforcing anything on the first floor. Even the code pretty well clearly states if the elevator opens into a rated corridor, you do have to protect that space. So different ways to protect the hoistway. Once we determine it has to be protected. Elevator lobbies are really common, really simple. Most commonly used when there's a lot of hoistways. For one or two, I don't think it makes economic sense. And then you put hold open doors to create this elevator lobby. Another way to do it is an additional door in front of each hoistway. Fairly simple. This is the cheapest way to protect hoistways. A couple things to keep in mind is if you're putting a hold open door in front of an elevator, it has to have a window in it. So these vision panels are really taking, the doors were already ugly. Now we're putting windows in them. So even a bigger setback there. And that window, you have to be able to see from the hoistway out into the corridor when the hoistway is only 25% open. So that really determines where that window goes in the door. If this elevator was a biparting door, we'd be putting a window right in the center. This is a little tricky. We've got door manufacturers that sell doors that are over 48 inches wide. In fact, I sell one. I sell a door that's up to 52 inches wide. Stuck in the IBC and in the legacy code, it's been in there forever, is a section that says the maximum width of a single door leaf shall be 48 inches. So we're selling doors that are wider than the code allows. So that's something to keep in mind is every once in a while an AHJ does catch this and says there's absolutely no way you're going to put a 52-inch door in because it's not allowed by code. Another way to protect the hoistway is shaft pressurization. It's really common in high rises. I think it gets very costly in low and mid rises. It's also tricky with the temperature swings we have just in the city of Denver. We have 100-degree plus temperature swing throughout the year. So there's always stack pressure throughout an elevator shaft. But with shaft protection, or with the shaft pressurization, we're trying to pressurize that shaft against the stack pressure to prevent smoke from getting into the shaft from a floor. So it's really tricky. Engineering is complicated and expensive, and maintenance is also expensive on these ventilation systems. And then there's the magnetic gasking systems. These roll down in front of a hoistway. They've got flexible magnets on both jambs that adhere it to either the elevator frame or an adjacent rail. The curtains are already translucent, or transparent, so you can see through it, so we don't have to worry about that vision panel. So it's a really simple system, compact up in the ceiling. Again, with the vision panel, it's kind of an unobstructed view for the first responders. Here's kind of a quick look of one operating. It's got that trap door that drops down as the unit's rolling down. It seals down to the floor, and again, seals to the jambs with that flexible magnet. There's an egress button right in the center of the curtain that can be pushed. It'll roll the curtain back up, time out, and then close again. And then once the fire alarm is cleared, the units automatically roll back up into the head, and unless it's a real budget unit, it closes this little trap door behind it. So super self-contained, really compact unit. This is a project we're still working on. Actually, it's we're under construction, but we haven't gotten products installed yet. I had mentioned before communicative stairs and exit stairways. We're trying to open stairs up for ventilation, and we're trying to really push people to use these stairs more and more, as far as, just as we're moving through a building versus, locking ourselves in elevators to switch floors. So definitely a much healthier environment. People don't like using stairs buried in the corner of a building. They're dark, they stink, they're cold, and there's safety concerns. So in a project like this, we've got accordion doors that we're opening up. So you've really got an open stairway unless there's an emergency. It's an open stairway. So, it's well lit, it's well ventilated, it doesn't stink. So and the safety factor is there. It's just an open stairs. So you really don't have to worry about, going into these dark stairs like a lot of people are concerned about. And egress, obviously we have to be able to egress onto these stairs. So the lower section is completely open. There's an accordion fire door that's going to close that space off. And then the upper portion between the columns is another accordion that has that egress swing door incorporated into it. So people can, we don't have to worry about the accordion with the paddle. This is an egress door and a fail-safe product that closes off and allows for people to egress, from each floor onto this interior exit stairway. Here's an example of the product that's going to be used. It accordions across the opening. The advantage of the accordion is the pockets don't have to be nearly as deep. They do take a little width, right, up to 16 inches of width for that accordion, but we lose about 40% of the depth requirements by folding an accordion up. And then you can see when the accordion's across, there's again that smoke protection. Even if this door gets held open, we've still got smoke and heat protection up above the door. Horizontal exits, it's a great tool. It's a requirement in most hospital applications, but it can be used in other applications as well. This is a project we did, it's the Transamerica's office downtown. They've got the top 3 floors of this building. And what they were doing is this lounge space, the top right corner of the plan, once a month, they were going to have their corporate meetings in there. So suddenly they're turning a B occupancy into an assembly space. And there were egress concerns with the occupancy. So with this horizontal exit, a couple rules: it has to go from exterior wall to exterior wall. It has to have egress on each side of it. So there's a stairway to the right, and then there's a stairway to the left of the horizontal exit. And in hospitals, what we use them for is fire rarely leaves the room of origin. Smoke does leave more often. But if we're closing these spaces off with smoke and fire doors, we're containing smoke as well. But in a hospital, it's really dangerous to get people out of a building, and it takes a lot of time. So a horizontal exit actually allows for a defend in place area. So should there be a fire on one side of this horizontal exit, we can move everybody to the other side and either not worry about it because the fire gets put out quickly, or with this 90-minute opening protective, we've got a lot more time to slowly and safely get people out of a building. So not only hospitals, but in like this B occupancy, it also increases our egress times, and we can get up to 50% of the occupancy in this space to go through this horizontal exit and then again slowly exit out of a building. So it actually lets us cheat a little bit and increase the occupancy load of a building without punching another stairway 52 stories down through this high rise. So we used a couple different products. This is an accordion fire door at the bottom half of this picture below the elevator core. They wanted to keep this workspace as open as possible. And then just above the elevator core is another fire-rated accordion door there. One thing to keep in mind in fire barriers and fire walls is opening protectives are limited to 25% of the length of the wall. So we can only penetrate 25% of this wall. So if you look at this highlighted wall thinking you probably would have designed it differently, you could have made this fire barrier wall much shorter. This was intentional, trying to make this wall as long as possible to increase that 25%. Then there's the end result with the accordion door closed across this space. Another project we've done, this is Children's Hospital down in Colorado Springs. This is the front entrance. They really wanted this space to be as wide as possible, as well lit as possible. I don't think hospitals worry about ventilation as much as we do with other buildings trying to circulate. But they just wanted this opening as nice and big and friendly as possible, including to the point you see the little color lights underneath the second floor deck. Those lights look like little balloons, helium balloons stuck to the ceiling. It's just a really cool space. But the life safety code also requires these floors be separated. So should there be a fire in this building, we're closing off the second floor mezzanine from the first floor. So we're completely isolating the two floors to meet the life safety code requirements. This is a great project we did downtown Denver, this beautiful 4-story convenience stair. It's a big atrium space. Even though there's a stair in it, they don't take enough space to make it what do you call a convenience stair? I don't know. Anyway, I'm sorry. It's an atrium. But we had to close it off. It does have a smoke control system, but we had to reduce the area that accompanied this atrium space so that the smoke control was large enough to operate. So we've got windows in conference spaces and some office spaces here to close that off. And this is a live smoke test we had done. You can see the smoke going up through the space. There's slots around the top of the atrium space for the fans. It's disguised really well. We're going to hear the fire doors start to close. So throughout the building, we've got these fire-rated curtains and some hold-open doors throughout the building that contain this space and allow for the smoke control system to be adequate to pull the smoke out of here. If you guys ever get a chance to do a live smoke test, it's worth it. It's usually done at night, it seems like, but it's worth it. And then down on the lower floor of this building, through this, you can see the stair ending here on this is actually the second floor of the building. And you see these subtle slots in the wall here. We've also put a side-acting fire door with egress there. So we're closing off that space from the atrium and still allowing for egress. Another project we're working on is this building. This looks like the exterior of a building, but we're actually in an atrium space in this photo. It's a 3-story, just a huge atrium, almost a mall feel to this space. They're putting a coffee shop in, and really wanted these spaces to be as open as possible. So we're pulling the storefront system out of both of these openings. You can see it again here, and putting these folding door systems in. They've got UL 1784 smoke test rating. So we're opening these up for this cafe, but should there be an emergency, they're closing it down to make sure that that atrium is separated from the retail space. Just kind of a look for what those doors will look like when they're finished. We'll get them in the presentation as soon as we get the doors installed. Another atrium space in a high rise. This was a fun project. This is a photo of DaVita's world headquarters, which is a really cool building. We've got a lot of fire doors and such up on the top floor, which is where the cafeteria is. It's really nice of the management to decide to make that the employees' space. They've got a great deck, great lounge and stuff up above it. But to the right of this bridge is DaVita's headquarters number 2, we call it. And it's got open spaces. There's 3 separate atriums, and each one of those is 3 stories tall. So throughout the building, there's some really cool openings, great spaces. And again, we're closing these horizontal spaces up between the floors with these horizontal shutters to eliminate the need for any tricky smoke control systems, especially already when there's smoke control in a high rise already. Adding it to these atrium spaces makes it very tricky. So there's the end result. In the left picture, you can see this really cool open atrium. Every opening had a different shape, so it was really a fun way to kind of shake the space up. And then you can see the horizontal shutter in this right photo. It's about halfway closed, just kind of as an example, so you can see where the tracks are and where the door actually operates from. So again, we eliminated the need for re-engineering with these atrium spaces because we closed it off with this smoke and fire rated opening protective. And that is it. I don't know if there's more questions.
I think we got to all the questions that were sent through the chat, Keith.
Oh, okay. Went a little quick with that one. Are there any other questions?
Yeah, we got time for a couple more questions if anybody would like to ask them now.
I love the birds in the background, Mike. That's great.
Yeah, it's not a fake background. It's the real deal.
Nice.
Yeah, if I was outside, you'd have heard 2 trains during the presentation. So it's not quite the same environment.
Well, we're grateful to have this overview. There's a lot more options and more coming all the time. One question I had, though, Keith, was how many of these options apply to a historic renovation? Can they be adapted for that? Because I appreciate all the examples, but they all seem to be for new construction, except in a couple of cases, like you mentioned with the plan there at the end with Transamerica.
Sure. In TI work, we do it a lot. It's a lot of what we're seeing is elevator lobbies. We're putting curtains in because they're so much more compact. People are either pulling out the hold open fire doors or they're putting in security lobbies, right? We're seeing these glass security lobbies put in. So we're using curtains in conjunction with those to keep, to maintain the integrity of the elevator lobby itself. So that's real common in TI work. We've got a historic project we're looking at in Montrose. It's an open atrium in a 100-year-old building. And you just can't bring it up to code. We've got a horizontal fire shutter, like the steel one that you saw, but we've actually got a fabric one that is available. Most AHJs don't like a horizontal fabric, but the structure wouldn't hold the steel one. So this is, the AHJ working with the architects and the engineers to try to make this building as safe as possible. So the compact, containment of it and the lightness of the curtain make it a product we can put in this existing space. And it's not quite prescriptive, but it's they understand we're doing the best we can, without changing the intent of the original building.
Well, we won't keep anybody any longer than we have to. I think you gave them all they could handle. So, thanks, Keith, and good to see you again, Gary. We appreciate all that Powers Products does and all the options that you have available for people here in the profession. Let's figure out how to sell tickets to the next few smoke tests for people. That might be interesting too. So as we wrap up today, I want to thank, of course, our partners at Powers Products, and just remind people that they are one of, as you see here on the screen, several of our partners who make it possible to join at no cost for our members. And then coming up next Wednesday, our Virtual Connect is hosted by the Business of Architecture Knowledge Community. Those are your member peers from across the state. They're doing a panel discussion on firm ownership, and industry experts will talk about everything from acquisitions to the valuation process, starting a firm and winding down. And I want to remind everybody of our signature event coming up very soon, our awards presentation. The call for entries is open now, and the deadline is coming up June 15th. So start gathering information to submit your great projects, nominate firms and individuals for award consideration. We know there's a lot of things to celebrate out there, and we want to do it with you. So thanks again for joining us, and we hope to see you soon. Take care.
Thanks, Mike.